Hi guys, we're going to look at the 3 sample problems in volumetric analysis notes. Now I know they're long notes, but be sure you do read through the ones before the sample problem at some point. This is actually a review from grade 11. We're going to be using C equals N over V and mole to mole ratio a lot. So if you look at number 1, find the concentration of H2SO4 solution if 15 mLs of it's needed to neutralize 40 mLs of 0.6 molar NaOH. So we're going to start out finding the number of moles of NaOH by using C equals N over V. So C is 0.6, N is what we're trying to find, and volume is 40 milliliters, which we have to put into liters, so it's 0.04 liters. So we cross multiply, and N is going to be 0.024 moles of NaOH. Now we need moles of H2SO4. So we're going to use a mole to mole ratio to convert my moles of NaOH into moles of H2SO4. Now remember, the mole to mole ratio is coming from the balanced chemical equation that I rewrote up at the top. So the number of moles that we should get is 0.012 moles of H2SO4. So now we're going to find the concentration of H2SO4 using C equals N over V. We have 0.012 moles, and you divide by the volume in the question, which was 15 milliliters, so 0.015 liters, and you get a final answer of 0.80 molars of H2SO4. So hopefully this is review and you remember it from last year. So in this question, we were given 13.4 grams of sodium carbonate, and we want to know what volume of 3 molar hydrochloric acid can be neutralized by the sodium carbonate. So step 1 after writing your equation is you take your 13.4, wow, that's great writing, 13.4 grams of Na2CO3, and we times by 1 mole over 106 grams of Na2CO3. Now we want to get it into moles of HCl, so I times by 2 moles of HCl over 1 mole Na2CO3. Now you'll notice I rounded up the molar mass to 106. You can leave it with a decimal, that's actually even better. But regardless, you should get an answer of around 2.252 moles of HCl. So then we can find the concentration, or the volume for HCl, by using C equals N over V. So our concentration is 3. We have 0.252 moles, and we need to find V. So we cross multiply again, but basically our 3 and our V switch spots. So the volume works out to be 0.084 liters. Now try that. Make sure you can get the calculations before you move on. Now sample problem 3 is percent purity using volumetric analysis. So we take the stuff we learned in 1 and 2 and we're going to find out how much pure sample we have. So there's 250 milliliters of 0.3 HCl required to react completely with the 5-gram sample of the impure salt. Now remember, you leave the 5-gram sample of impure till the end when you do percent purity. We're only using the first 2 numbers in the question. So I'm going to go C equals N over V and find my number of moles of HCl. So I have 0.3 equals N over 0.25. I cross multiply, and I get 0.075 moles HCl. And then I'm going to start with that, and I'm going to convert into moles of Na2CO3, which is sodium carbonate. So we have 1 mole of Na2CO3, and that came from in front of here, over 2 moles of HCl. Again, the 2. Then because I need grams of Na2CO3, I need to times by the molar mass. And again, I rounded off. I'm not sure why. You don't have to. You can use decimals. It's actually better. and that's going to equal 3.98 grams, and that's your pure substance. So then to do percent purity, you take your pure, you divide by your impure, and you times by 100. Again, we did this in grade 11. So in this case, we have 3.98 from our question that we calculated, divided by 5, which came from the actual question, times 100, and you should get 79.6%. Again, try the math from your notes before you try the assignment. And make sure you hit those deadlines, because I'll be putting marks into Maplewood.